Alright, so let's talk about some derivative rules. You should recall that we can figure out the derivative in this rather labor-intensive way called the limit definition of the derivative that says f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. It's a useful formula, but it's really a pain. And a lot of the times this is way more work than you need to do. So because you understand the reason for this, and you recall that a derivative is nothing more than we've got some function, f of x, and we've got some point on that function. The derivative is just a line that is tangential to that point on the function. Alright, so this line right here is f prime, pretty much, f of x prime. And so we can evaluate the derivative at a point, or we can use this to evaluate the derivative of an entire function and come up with another function that is the derivative of that function. So instead of evaluating it at this point, we can get f prime of x, and this allows us to just go and start plugging in points anywhere we want and figure out the derivative over the entire function, and when we plug in any point that we want, we can get the derivative at that point. We just get a new function. So that's the beauty of that. So what we can do with this, now that we understand the graphical basis of tangent lines that is the derivative, and why the limit definition of the derivative works, there are a couple of really cool rules that we can do to make our lives easier. So the first one is really easy, and this will just call this a rule for constants, okay, or the constant rule. The constant rule is going to tell us that C prime is always 0. Now, another way to write this that's a little bit more correct is to say that for f of x equals c, if we have that, then we already understand that we can say all of this limit definition of the derivative going in and plugging in c for our f of x and our h, and then when our limit ends up going to 0, we're just going to have that c prime is always 0. There's a reason for this, though, that we don't really have to even think about the limit definition of the derivative to understand this. C prime is always 0 because what does a constant look like on a function? So if we just graph 6 or we just graph 7 or something, we're just going to get on that function a straight line, right? So a line that's tangential to a straight line is, well, it's the exact same line, right? There is no change in the slope. So a line tangential to a line is just that line itself. So the slope of the tangent line to a line has a slope of 0. It has a slope of nothing. So that is why this rule works. So that's the constant rule, that C prime is always 0. So we'll go ahead and write this in our arsenal over here. We know that C prime always equals 0. Well, what about the derivative of just x? Well, x prime is always 1. Always. We never need to worry about this. Why is this the case? Let's go ahead and just graph y equals x. Here's the graph of y equals x. And the line tangent to this line, because this line isn't flat, it's the line itself. What's the slope of y equals x? Well, it's just 1. We can determine that algebraically. So the prime of 1 is always going to be, the prime of x, I'm sorry, the prime of 1 would be 0. The prime of x is always just going to be 1, because that's the slope of that tangent line. Now, there's a rule for constants times a function. If we have c times f, and we want to take the derivative of this, it might be intuitively, algebraically, a good idea at first thought to say, okay, well, we know that c prime is always equal to 0, so this is just 0 to, okay, this is also going to be 0. Well, it doesn't work that way. Well, the first reason it doesn't work that way is because of the product rule, which we'll talk about in a minute. But here's what we really need to do. A constant times a function the prime of that is always the constant itself times the function prime. So an example of this is like, what is 3x squared prime? Well, we have a constant times a function, so we'll just keep that constant times x squared prime, which is 2x. So this is just 3 times 2x. So let's write our rules over here. We said constant x prime is always 1. A constant times a function prime is always the constant times the function prime. Now, what else can we do? Well, here's a really good one. Let's talk about the sum rule. This is really easy, the sum and difference rule. So, we have a function here, f plus or minus g prime is always equal to f prime plus or minus g prime. This is really intuitive and really simple. All this is saying is, and it looks like, what did we do? All we did was just, we took off the parentheses and added prime to each thing. Well, the reason this is intuitive and the reason that this works, the reason that it's important is because we can break this up now. We can take any sum that we have, and when these functions get really complicated, this is going to make our lives a lot simpler. We can just say, okay, break them up, we'll evaluate this one, then we'll evaluate that one, and then we just get what we get left over. So that's an important rule. So f plus or minus g, all that prime is f prime plus or minus g prime. So this is our sum or difference rule. F plus or minus g prime is f prime plus or minus g. And I say plus or minus because it works for sums and for differences. It doesn't matter at all. All right, let's go ahead and talk about the power rule. Power rule, it says if we have x to the nth power and we want to take the prime of this, well, here's what we can do. Let's just pull this n down in front of the function, and we're going to get n times x to the n minus 1 power. So let's say this is, an example of this, let's say x to the 6th prime. This is just 6x to the 5th, because 6 is our n, so n minus 1 is just 5. So we're pulling the 6 down in front of the x, and then we're subtracting 1 from it and sticking it right there. So x to the nth power prime is just n times x to the n minus 1. Another convenient rule. Let's talk about if we have products. Let's talk about things being multiplied together with one another. So let's say we have a function f times g, all of this prime. Well, there are 2 right answers to this. We can say f prime times g plus f times g prime, or we can say f times g prime plus f prime times g. These mean the exact same thing. This is just the commutative property of addition. It doesn't matter what order we put things in, because when we and multiplication, it doesn't matter. 6 times 5 is the same thing as 5 times 6. So that's why this works. So we'll just keep this top one as our poster child favorite for the moment and say, because it really doesn't matter at all, it's up to personal preference, f times g prime is just equal to f prime g plus f g prime. So look, we got quite a number of rules over here. Let's go ahead and talk about the quotient rule. So what do we do when we're dividing things, when we have the prime of a rational? So, if we have f over g, and we want to take the prime of all of this, well, there's a little, it's not a mnemonic, but it's kind of like a rhyme that we can do to help ourselves with this. The denominator is just going to be g squared, so that's easy, we don't have to worry about that. But on the top we have low d high minus high d low. So we have low d high, we have g f prime, low d high, minus high d low, minus the top, high, that's what we mean by high d, f g prime. And this is our quotient rule. So let's write this over here. F divided by g prime is equal to g, I'm sorry, not f, g f prime minus f g prime over g squared. So there are some more rules we can work with, but for now this is simple, and these are the basic rules you need to go ahead and get started. And this is so much easier, I think you'll agree, than taking the limit definition of the derivative for everything, which is just yucky and painful and too much work most of the time. So constant rule. What we would know, constant prime is always 0, x prime is always 1, c times f prime is always c times f prime. F plus or minus g prime is f prime plus or minus g prime. X to the nth prime is n times x to the n minus 1. And f times g prime is f prime g plus f g prime. And f over g, all that prime, is gf prime minus fg prime over g squared. So that's all there is to this. I apologize, I nearly forgot. Let's talk about one more important rule that I really think a video on rules for the derivative, ways to cheat and make your life easier, would be completely incomplete without. E to the x. What's e to the x prime? We know e is a really important number, equal to a little bit over 2. More about that in a different video. We don't have time to go into that here. But e to the x, this is going to be something, e is something we're going to find in derivatives very frequently. So being able to know e to the x, or an exponential function of e, what the derivative of that is going to be important. Thankfully, this rule is crazy easy and even more helpful. E to the x, when we take its derivative, is e to the x. It's the same thing. So I know you haven't, if you're watching my videos in order, we haven't talked about second or third derivatives or anything like that yet, but basically there's an idea in calculus that, okay, we've taken the first derivative, well, we could take the second derivative of something, which says take the derivative and then take the derivative of that derivative. We could take a third derivative, which says, we'll get something here, and then we can take its derivative. So however many, and then we could go up to a fourth derivative, which means take the derivative, then take the derivative of that derivative, then take the derivative of that derivative, then take the derivative of that derivative. We can do this as many times as we want. After about 4 times, it's completely useless to any actual real-world application. But the beauty of e to the x is it's a function that you know what the derivative is no matter what number's right up here. The e to the x, the 18 millionth derivative of e to the x is e to the x, because every time we take prime, it won't change. E to the x prime is always e to the x, no matter how many times we keep taking its derivative. The slope of its tangent line is itself, so that is crazy important. I think another function like this is, of course, the derivative of 0 is itself, right? Because it's just a constant. 0 is just a constant. But this is an important rule, so definitely let's add this to the arsenal. E to the x prime is always just e to the x.